Hi, in this lecture, we'll be talking about list comprehensions. List comprehensions are used to create lists. They can be used instead of a couple of functions we discussed before, the lambda function, the map function, and the filter function. They cover the functionality of them all. If you want to learn more about the lambda function, the map function, and the filter function, I have a video on each of them, so feel free to watch them first. In a list comprehension, we tell the program to do something to each element of an iterable, like a string, list, range, or any other iterable. I also have a video on iterables and iterators, so you can watch it too, if you want. Let's start with something simple. Suppose we need a list of even numbers up to 20. We can accomplish this with a for loop, the filter function with the lambda, or a list comprehension. Let's compare the three solutions. Here's the version with a for loop. Even numbers equals an empty list for number in range 21. This generates numbers up to 20. If number modulus 2 equals 0, which means if this number is divisible by 2, even numbers append number. Fine. And now let's print out the even numbers. 0, 2, 4, 6, and so on. So it works. And now the version with the filter function with the lambda. Even numbers equals list filter lambda number modulus 2 equals 0. Range 21. Fine. And now let's print our even numbers. And we get the same output. Finally, the most concise and readable version with a list comprehension. Even numbers equals square bracket. We use square brackets for list comprehensions. Number for number in range 21 if number modulus 2 equals 0. Enter even numbers, and the result is the same. So here's our list comprehension in square brackets, just as list. And this list comprehension creates a list. And this list contains elements which are created like so. Each number is taken from this range if this condition is met. So if the number is divisible by 2, and this number is returned as an element of list. Now, although we get the same result in the three cases, the for loop is slower than the filter function or the list comprehension, which may matter in more complex examples. In list comprehensions, the loop variable is local and has no effect on global variables with the same name. Let's have a look. X equals hello. So this is global X. Now let's create a list using a list comprehension. This time odd numbers. Odd numbers equals square brackets X for X in range 20 if x modulus 2. Now this means if x modulus 2 is true, which means it's not equal to 0. So it means there is a remainder, and this number will be odd. And here we have a local x. So this is a global x, and this is a local x defined in the list comprehension. Now let's print odd numbers. Fine. And now let's print the global x. Hello. So as you can see, the value of this global x is retained. Okay, and here's an example in which the program adds the .pdf extension at the end of each file name in the files list. So here's our files list. My cat, sister smoking in sir, disappearing dinner, for example. And now, full names equals file plus the .pdf extension for file in files. And now full names is the following list: mycat.pdf, sister smoking in cellar.pdf, disappearing dinner.pdf. So here each element in this iterable is taken and used like so. This element is used along with this extension. They're concatenated, and what is returned is an element containing this extension. And now an example with numbers. First we turn the numbers into binary numbers, and in the other comprehension we use a formula to change the values. So, decimal numbers is a list of the following numbers: 4, 7, 8, 11. Now binary numbers is another list created using a list comprehension like so: bin of n, which returns the binary representation of a number, for n in decimal numbers. Fine. Let's print binary numbers. Binary numbers, okay. As we can see here, we have the binary representations of these numbers. This is 4, this is 7, and so on. And now let's use another list comprehension. Encoded equals 2 times n minus 1 for n in decimal numbers. And let's print our new list, encoded, and this is what we get. So this operation is carried out on each element of this iterable, and the result of the operation is returned as an element of this list, encoded. We can also use multiple variables in a list comprehension. Here's an example that will print all the Pythagorean triples such that each integer will be less than 100. What's a Pythagorean triple? It's a group of 3 positive integers a, b, and c such that a squared plus b squared equals c squared. So here's the code. Pythagorean triples equals, and here's our list comprehension. We'll use 3 variables: x, y, z. For x in range 1 to 100, for y in range x to 100, for z in range y to 100 if x to the power of 2 plus y to the power of 2 equals z to the power of 2. So, this is our comprehension. As you can see, it's quite lengthy and not very readable. So, for better readability, we can rewrite it like so. xyz for x in range 1 to 100, for y in range x to 100, for z in range y to 100. If x squared plus y squared equals z squared. Okay. And now let's print the triples. And here they are. Now, if you take any of them and you square the first number and add to it the square of the second number, the result will be equal to the square of the third number. These are the Pythagorean triples. But again, here all the results are on one line, which is not very readable. So, for better readability, let's print them out like so. For triple in Pythagorean triples, print the following formatted string. A equals triple 0, which is the first element in each tuple. B equals triple 1. C equals triple 2. Okay? And now the output is much more readable. For example, 3 squared is 9. 4 squared is 16. 9 plus 16 equals 25, which is equal to 5 squared, and so on. We can also use a list comprehension for the cross product of two sets. The cross product, also known as the Cartesian product of set A and B, is a set of all the pairs of elements of which one element belongs to set A and the other to set B. So what we get are all the possible combinations. Here's an example. First, let's define the two sets. Actually, here these are lists that we want to work on. And the first one is verbs equals get set give. The other list is particles equals up, in, on, off. We want to combine simple verbs with particles to make phrasal verbs. Phrasal verbs are verbs usually consisting of two words, like for example, make up, show off, turn on, and many others. So, let's do it like so. Phrasal verbs equals. Now list comprehension. And I want to combine in a tuple the verb and the particle. So, verb, particle, for verb in verbs, for particle in particles. Now let's print phrasal verbs. As we can see, what we get is a list of two tuples of comma-separated parts of phrasal verbs. Now we can use the phrasal verbs list, so this one, in another list comprehension to get a list of strings, each being a full phrasal verb. So we don't want it to be get, comma, up. We want this to be one string, get up, get in, get on, get off, sit up, and so on. So let's use another list comprehension like so. Phrasals equals, here we have a list comprehension, and in the list comprehension we want to have formatted strings that look like so. Verb 0 space verb 1 for verb and phrasal verbs, which means for each element in this list here, this is the first element, the second element, and so on. So for each element, make the following formatted string. Take the first element, add a space, and take the second element. So here we should get up. Let's check it out. Phrasals. Yeah, that's exactly what we wanted. Get up, get in, get on, and so on. Now, although we should keep list comprehension simple, we could achieve the same in just one step. So here are our two lists, again, verbs and particles. And now we can just omit the stage with two tuples and create a list of strings. So phrasals equals f string verb 0 space verb 1 for verb n, and here we have a nested list comprehension. Verb particle for verb in verbs for particle in particles. Okay, let's print out phrasals. It works. Get up, get in, get on, and so on. Well, such nested comprehensions let you save some typing, but they also obfuscate your code, so it's usually better to keep them simple. And here's some more examples of list comprehensions. Suppose we have the following numbers list, and now we want to create a list of squared numbers. It's very simple. N to the power of 2 for n in numbers. And here we have the squares. Now how about odd numbers? N for n in numbers if n modulus 2. And now we get the odd numbers. How about the absolute values of the numbers? Okay, ABS, this is the function that returns absolute values. ABS of n for n in numbers. And now we get the absolute values. So the absolute value of -5 is 5. The absolute value of -3 is 3, and so on. And now strings containing number characters. So number plus the string representation of the number for n in numbers. Number -5, number -3, and so on. And how about numbers with their opposites as tuples? So we want each element to be a tuple consisting of a number and the opposite of the number, so -n. For n in numbers. And now we get -5, 5, -3, 3, 0, 0, 4, -4, and so on. And now how about Boolean representations of numbers? Okay, so bool of n for n in numbers. And this is what we get. Well, actually, 0 is regarded as false, and all other numbers are true. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.